We've all been there. You're sitting peacefully and suddenly a housefly decides your personal space is its new playground. You wind up, take the perfect swing, and nothing but air. The fly is already on the ceiling mocking you. You didn't even get close. And this happens basically every single time. So why is a creature with a brain smaller than a grain of rice consistently better at dodging you than you are at catching it? The answer comes down to a few specific biological advantages that genuinely stack the odds against you from the very start. Flies process time differently than you do. The single biggest factor is something called flicker fusion rate, which is essentially how many separate visual frames per second a creature's eyes and brain can process under normal conditions. Humans process visual information at roughly 60 frames per second. Flies process visual information at closer to 250 frames per second. What that means practically is almost unfair. To a fly, your hand isn't moving fast at all. It's moving in what would essentially look like slow motion, the same way a slow-moving object looks obvious and easy to dodge to you. Your swing that feels lightning fast from your perspective looks like a lazy, telegraphed movement from the fly's perspective, with plenty of time to react and escape. This faster visual processing pairs with an extremely short neural response pathway. A fly's decision to move from detecting a threat to actually engaging its wing muscles takes a matter of milliseconds, dramatically faster than the equivalent reaction chain in a human. Human reaction time to a simple visual stimulus typically sits somewhere around 200 to 250 milliseconds. A fly can begin evasive action in a fraction of that time. By the time your brain has even finished registering that your hand is in motion and adjusting your swing, the fly has already processed the incoming threat, calculated an escape trajectory, and started moving. Here's the part that feels almost like cheating. Researchers studying fly escape behavior have found that flies don't just react to a hand once it's already swinging toward them. They pick up on much earlier cues, subtle shifts in light, air pressure changes, or the visual approach of an object well before the swing itself, and they begin calculating an escape route in advance. This means the fly isn't reacting to your swing at all. In a very real sense, it's already reacting to your intention to swing, based on the earliest possible physical signals your body gives off before the motion even fully begins. Once a fly commits to escaping, its actual flight capability is remarkable in its own right. Flies can execute extremely rapid changes in direction, sometimes altering their flight path within a few wing beats, using specialized organs called halters, small club-shaped structures that function like built-in gyroscopes, providing constant, extremely fast feedback about orientation and rotation during flight. This lets a fly perform tight, sudden maneuvers that would be physically impossible for something without this kind of specialized stabilizing system, allowing it to essentially juke around an incoming hand with far more precision and speed than the size of its brain would ever suggest. There's also a purely physical disadvantage working against you specifically. Human hands and arms are relatively large, and moving them generate detectable air pressure changes and visual displacement well before contact actually occurs. Flies have sensory hairs across their bodies, capable of detecting subtle air movement, essentially giving them an early warning system for incoming objects that doesn't rely on vision at all. This means even a perfectly executed silent swing still displaces air in a way the fly can sense and react to before your hand physically arrives. So is it actually hopeless? Not entirely, but the fly does have every meaningful advantage stacked in its favor. This is actually why experienced fly swatting technique tends to focus less on speed and more on approach angle and anticipation, striking from above and slightly ahead of a fly's position, rather than directly at it, since flies most often launch upward and backward as their default escape response. Understanding that specific pattern is genuinely more useful than simply trying to move faster, since faster was never actually a fight you were going to win in the first place. If you're enjoying peeling back the surprising logic behind everyday annoyances like this, hit subscribe. A new one drops every week. So the next time a fly effortlessly dodges your best effort, know that you were never actually competing on a fair playing field. You were working with a visual system nearly 4 times slower, a reaction pathway measured in hundreds of milliseconds instead of dozens, and zero ability to detect a threat before it visibly moved. The fly, meanwhile, was already reacting to your intentions before your hand even finished swinging. It's not that you're slow, it's that evolution spent millions of years turning flies into some of the best last-second evasion specialists on the planet, and you're just the latest large, slow-moving object they've learned to easily outmaneuver.